Okay, I'm gonna go over the review again. The answers are here. So if you need to pause and just kind of be like, oh, why or why not? This mainly goes with the vertical line test. Now, this one I wanted to talk about because normally, remember, square root function, you should know, goes there. Now, sometimes people have a hard time knowing which way does it reflect. Do you see how that's impacting the output? So I know without using decimals that the output, the Y values are getting reflected. So I know it goes like that. Okay. But it does pass the vertical line test. So yes, passes vertical line test. So that's your, biggie if they do. Now this, yes, this is a passes. So the domain is actually just those, three inputs, because it's not infinity inputs. And then my range is what outputs 2 and 7, and we don't do repeats. This one is no. Now this one is different because there's infinite many. So the domain starts at 0 inclusive, goes to what? Positive infinity. Okay. The range, we start low, so there would be negative infinity values, and we stop at 0. So this gets interval notation because it's a continuous, function, has tons of values. This only has certain ones because it's not connected. All right. Down here, you can look at the answers. If you guys find any errors, please email me so I can fix them. All right. I did my best to double check. Subbing in negatives, be careful, put parentheses because it's a negative times a negative. There's no way that can be negative. It has to be positive. So watch that. Here, okay, this one, there was one like this on the quiz. I'm giving you the output. So you have to solve it. Most of you did that well, but remember, polynomials degree 2, it for sure has 2 answers. So when I square root both sides, get in the habit of plus or minus. So plus or minus square root of 44, we usually simplify that. 4 comes out and 11 stays. 4 has a square root, so we get 2 radical 11. Okay, so again, expect 2 answers if you have an exponent of 2. The only way you wouldn't is if it's 0. All right, adding, this is just adding, write them down, collect like terms. Subtracting, be careful because remember, anytime you subtract, you have to distribute that negative. So add the opposite. Okay, so what's that going to give me? Positive x squared, negative on the x, and negative 60 in that. I think that's what, negative 12. Okay, so just know that, be careful with distributive. Here, this is not a composite function. That's when you do the open dot, like the fog thing, or you do f of g of x. This is just simply multiplying. So just FOIL them out or do the box. I got that. Again, if I made a dumb mistake, let me know. Dividing, and again, watch your order because that matters. I'm going to put the f function on top, the g function on bottom. See if you can factor. I can. So this is my answer, except this guy would be a whole, right? Like he can't exist because dividing by 0 is a no. All right. Again, if you need to pause to look, at any of these answers and read what I said, or if you need an explanation and I didn't give one, let me know. All right, I'm going to pause. We're going to go to page 2. All right, the top of the next page asks for the domain and range of this guy. This function is going to look like a line. It's just going to have a hole where it can't be 4. So basically, all reals are okay for the domain and range, except the domain, 4 is not allowed. And for the range, if you sub 4 in, 4 plus 4 is 8, there's no way to get an answer of 8. So you could say all reals, not that, all reals, not that. You could do negative infinity to 4, parentheses, union 4 to infinity, and then same thing here. You could go negative infinity, comma 8, parentheses, union 8, to infinity if you want to. Either way. All right, let's look at the next one. Inverse functions, you just swap input for output and do the inverse, okay? So inverse, subtracting, inverse, dividing, inverse, square rooting, inverse, adding 4. And your answer should have the reverse elements. So it should have a dividing by 3 instead of minus 4. It should have an add 4 somewhere. It should have a square root somewhere. Should have a minus 7. And the process will help you know where those should all go. All right, number 4 goes with this graph. So when I look at 4, I see an output of a negative 1. When I look at input of 2, I see an output of 1. Now this one, you have to be careful. This is an output of 2. That's about right here. This one's marked. This one's there. It doesn't have a big dot there. But at a negative 3, you have a value. And it looks like at 5, you have a value. Even odd, there's no symmetry to the origin or to the y-axis. So none of that. And then there's no symmetry at all. Domain is all and all because these go off to infinity. Okay, increasing, put your little, track here. And again, I like to cross off the y values so I don't accidentally screw up. So from what, negative infinity to -3, it's increasing. It goes down from -3 to -1. From -1 back to 2, it's increasing again. 2 to 4, it's going down. And 4 to infinity, going up. All right. Again, if you need to pause this to look at the answers and email me if you have more questions. All right, I'm going to pause again. Okay, mine printed a little wonky, but x-intercepts are on the top of the next page it went to. X-intercepts are where it crosses the x-axis. Some of these are kind of hard to tell if they land exactly. So, I thought the 1 and the 3 did. This looked like 4.7 to me. Over here, it looked like a -2 and about a -4.1. So I had to estimate on a couple of them. That one I debated on. I wasn't sure if it was like, a little bit like 0.9. I don't know. But again, it's where it crosses the x-axis. The y-intercept is where it crosses the y-axis. That looked like a -2 to me, 0, -2. All right, what else? Oh, local max and mins. Now remember, locals have to be in the middle. Okay, they can never be on an end, ever. So this looks like a local max to me. That looks like a local max to me. And these are ordered pairs. That looks like a local min. That looks like a local min. Absolutes go off to infinity, goes off to negative infinity. I don't see any absolutes there. All right, next one, remember to test for even or odd, you sub in a -x for input and you see what happens. So I just subbed in a -x, the opposite of x, just to see. Here I got the same algebra, so it's even. Here I got opposite algebra, so it's odd. And with graphing, let me pull up Desmos quick. I have it here somewhere. Here we go. Let me hide this one. The first one is this, and you can see that's symmetrical to the y, so obviously even. And then let me hide that one. And then here's the other one. This one, can you see if you rotate it, if I take and rotate it in a circle, it's going to land on itself, so it has rotational symmetry around the origins. So that also makes it odd. Okay. All right, let me get back to this guy. I believe this one for sure, I think, was on one of our quizzes. So local max have to be in the middle. So can never be on an end. So that thing and that thing can never be locals. So it looks like there's 2 local maxes, right? 2 maxes up here. Looks like there's a local min in that area. Looks like this guy is the absolute minimum value you can have. The highest value, you're tied up here again, okay? And that point over there is nothing. Doesn't end up being anything. Here, same thing. Locals have to be in the middle, can never be at the end. So it looks like they're local max there, local max there. Again, I had to estimate a little bit because it wasn't quite on the point. Min is there, local min, absolute min. There isn't one because it goes off to infinity, but this guy would be your absolute max. All right, greatest integer function. Remember, I think the easiest way to do is graph and always go to the left because it's the greatest integer that is less than or equal to what's given. So if you go to the left is less than. Now, the only thing, this is going to the left, this is going to the left. If I give you the greatest integer function of, say, I don't know, -5, then the answer is -5 because it's less than or equal to. So the answer to that would be that, because obviously you wouldn't go to the left because you're on an integer. All right, I'm going to pause again and I will keep plugging away. Again, you can pause it if you need to see any of my work. And again, if you need detailed explanation, just email me and I can do more. Okay. Again, my print job wasn't great. Greatest integer, going to the left would be that. Going to the left would be that. Okay. Graphing a piecewise function. All right. How do I go about doing this? Well, I try to start with what I think is easy. I thought this is a constant function. This is saying when your input is 2, 3, 4, 5, a million, your output's always 5. So sub in 2, output 5. Sub in 3, output 5. And so I know that's a constant line. Okay. That is like, you getting paid $5 no matter how many hours, 2 hours all the way to whatever it takes to get the job done, you're going to get paid $5. Hopefully it's 5,000, but whatever. All right, so I did that one first. And again, if you want to make an input-output chart that no matter what your input is, 5. And notice this is not a whole, so I didn't write anything special. All right, let's look at this middle one. All right, so this is a line. I know that. It has positive slope, so better be going up. And you could start at 4 and go 1, 1, 1, 1, whatever, but you're kind of limited here. It could be -1, but that's a whole because it's not technically allowed, but you could get infinite close to it. 0 is allowed, 1's allowed, 2 is the same deal. You could be 1.9999999, but you can't really be 2. So you sub into, and the whole indicates you can get infinite close because as humans, we cannot graph 1.9999999. Okay, and we can't see it if we do. All right, so what I'm going to do here is then I put my whole at -1.3, put my whole at 2.6, and I drew my line in the middle. Okay, did that guy. All right, so now let's look at this one. Okay, so this one, I can have -1, that's great, and I'm going less than. So I did -1, -2, -3, -4, -5 to get a feel. Sub in -1. -1 squared is 1 + 1, output 2. 4 + 1, output 5. -3, 9 + 1, output 10. And that's about all I had space to graph. So -1, solid point, because it can land. -2, -3, input, output. And I know it's a parabola, so don't make this look like a line. It's like, I know it's pretty tight there, and you might be like, oh, it's a straight line. No, it's a squared, it's a parabola. So kind of get that curvy in there, right down there. All right, I'm gonna pause one more time and I'll keep going. Okay, graphing functions. You should know the transformation, the overall shape. This one is whatever causes 0 shifted to 3. I labeled that point. And then pick friendly points. 3 would give you 1, and 1 + 3 is 4. So at 3, 4, you have a point. Again, I went plug in everything. I'd be like, ooh, sub in 6. 6 - 2 is 4. So square root would be 2 + 5. And again, you know the overall shape, not reflected. This is a V not reflected. Again, I did my transformation, -1, 2. I know it's going to get skinnier. Again, subbing in to get the y-intercept is a good idea. 1 would be 3 + 2 is 5. And I didn't sub in the other one. Actually, I just reflected it because I know it has a line of symmetry. So I just did that and made sure it all worked. You can sub in -2. You'll get -1, which is still 1, 3, and 5. So you can do that. Same thing here. I knew the shift was -1, -3. Yeah, I didn't pay attention that it was reflected when I made my initial one, so I made a new one. I know it's reflected and a little skinnier than normal. Again, I subbed in 0 just to get the intercept, which is at, oh boy, Julie, what did I write there? 0, -5. And then I reflected it over to the -2 spot. Okay, and again, if you want to sub in -2, you can get -1, +1, and get it that way too. This guy, I knew it looked like a cubic right away. It could have been maybe 5th power, I don't know, but the graph is a little wonky, so I went to check. So I started with my cubic, and then I subbed in 1 and got an output of 1. I subbed in 2, got an output of 8. So I knew there wasn't any type of stretch or 5th power or anything like that. So I knew I got my cubic one. Okay, this one is a little tricky. I know it's a square root because of the shape. I know it's reflected because a normal square root, should look like that. So I know it's reflected, and I know the x values are reflected because the x's that used to be positive are now negative. And I know the transformation as far as where it starts, -1, 1. All right, so this is the kicker. Remember how, like, if this causes 0, that's your shift, and that is. So -1, -1. The problem is it's reflected. And so you have to make sure this is factored when you reflect it. Otherwise, that one gets messed up. So I need to distribute my negative, and I get that. And the nice thing is, like on the test, I'll give you the last 20 minutes to get our Desmos. Excuse me. So I could check my answer. So say I don't know, for some reason, say I had this, you can see, oh yeah, that's not right. Okay. So unfortunately with shifts or transformations, they do have to be in factored form, which is sometimes a problem. All right. I'm going to stop this video here. That's probably enough. Again, if you want to see these again, you can just pause it and, kind of you know, spend a little time thinking about them. All right, but I'm going to pause there and I will make another video on the rest of the review, or a couple more, just depending on